Okay, Algebra 1. Section 7.1. Adding and subtracting polynomials. Now, to get credit, you guys need to take notes. You need to copy everything down. I write down. It needs to look like mine. So let's get credit here. You should put your name at the top. The date. You should put the period. Your period in my class. Okay. Now, this should seem a lot easier than what we were doing in the last unit. So I think you guys will probably appreciate this. But there are some definitions, some terms and names that we need to know of things to start off the bat. So we're going to write down some of those things. So what is a polynomial? So a polynomial is a monomial, whatever that is, a monomial or sum of monomials. Okay, now poly means many. So that's where this comes in. It could have many terms, okay, many terms. So each, a term in a polynomial is each monomial ends up being a term. And I'll show you guys some examples, okay? A binomial is a polynomial, with two terms. And a trinomial keyword tri is a polynomial with three terms. So some examples, a monomial, mono usually means one. A monomial has one term like this, 5x. That's one term. I know there's a 5 and there's an x, but it all together. A binomial would be something like this, 5x plus 2. So the plus separates the terms. So terms are separated. We could add this, separated by addition or subtraction. Okay, so 1, 2 terms, binomial, 2, mono, 1. Trinomial, be something like this, x squared plus 5x plus 2. So the pluses separate the terms. So there's 1, 2, 3 terms, trinomial. Okay. Some other words that we need to know in terms that we need to know. Degree. The degree of a polynomial, and we're getting close to done with all the writing of words. The degree of a polynomial is the greatest degree of its terms. So that's still a little vague. Okay, but I'll show you in a second. Now, another word that we'll throw in there at the same time, standard form. So standard form is when the exponents decrease from left to right. So that means they're going from biggest to smallest. Okay? So here's an example of a polynomial. 2x cubed plus x squared minus 5x plus 12. Okay? So that's a polynomial. It's in standard form because it's going from the highest power down to lowest power. Okay? The degree is the highest power we see out. So the degree of this term right here is 3. The degree of this term is 2. The degree of this term is 1. And the degree of this term is 0. The highest one is your degree. So right here, this ends up being the degree of the whole polynomial. So the degree of the polynomial is 3. Okay? It's the greatest degree. So each term has a degree, which is just the powers on the variables. But the biggest one is the degree of the whole thing. We call the number in front of the first one, when it's written in standard form, we call that the leading coefficient. So coefficient is a fancy word for the number in front of variables. That's multiplying them. Leading, it's the first one, it's in front. The last term is kind of special because it doesn't have any variables on it. It's kind of like it has an x to the 0 power because anything 0 power is 1, right? But they call this the constant term. The reason they call it the constant term is because it never changes. When something's constant, it never changes. These ones, when x changes, they change. When x changes, this one doesn't change. This one's 12 no matter what. It's always 12. Let's do some examples. So, example 1. Find the degree of each polynomial. Okay? So we're going to do a few here. 5x squared, 8x cubed y cubed, 5x squared plus 8x cubed y cubed. Okay? So this is a monomial, one term. The degree of that term is 2, so the degree of the whole thing is 2. It's the highest power. Now this one, this is also a monomial. There's no addition or subtraction. This is one term. And the degree of this term is if you add all these up, all the powers up that are on variables in the same term. The degree of that term is 6. The degree of this one is a binomial. It has 2 terms. The degree of this term is 2. The degree of this one is 6. The degree of the whole polynomial is an 8. It's the biggest one out of those. Okay? Because these are separate terms. Here we added them, and here we added them just right there, but not all of them together. So that's the degree. Example 2. Write 15x minus x cubed plus 3 in standard form. Identify the degree and leading coefficient. Okay? So, first thing, I'm going to try and write in standard form. Standard form is highest power to lowest power. So, the x cubed is the highest power. It has a negative in front of it that belongs to it. Okay, then the next one is the 15x, and we put a plus because it's positive, and we need to put some kind of term, symbol between. And then the 3 is last. It has a degree of 0. So that's standard form. Now the degree of the whole thing, well, the degree of this term is 3, the degree of this term is 1, the degree of this term is 0. So the degree of the whole thing, do not add them up. They're all separate terms. The degree of the whole thing is 3. The leading coefficient is the number in front of the first term. It's this right here. And remember, if there's a negative, that's a 1. You could always write a 1. So leading coefficient is negative 1. Example 3. So now we're going to get into what the title of the section is. Adding polynomials. I don't think this will be too bad. Adding polynomials. So here's an example. 2x cubed minus 5x squared plus x, and we put it in parentheses, plus 2x squared plus x cubed minus 1. So there's like two polynomials here, trinomial and a trinomial, okay? The way we add polynomials together is all we do is we combine like terms. Combine like terms. What are like terms? Like terms have the same variable or variables, but also with the same exponents on them. So they got to match up. Like terms are terms that look like each other as far as the letters in them and the powers on the variables. What I would recommend doing, just to make it easier, is to rewrite this with the like terms from highest to lowest be next to each other. So 2x cubed, and I'm going to cross them off as I go so I don't like accidentally skip one or something. Plus x cubed, okay? Then minus 5x squared, and then plus 2x squared. Those are like each other. And then plus x, and then there's no other x terms, and then minus 1. So we're also going to have it in standard form by the time we're done. So that will be nice. Now, when you add like terms together, all you do is you add their coefficients. You just add the numbers in front. Do not add the powers. Do not add the exponents. Okay? I have 2x cubes and I have 1x cubed. How many x cubes do I have? It's like we're counting how many of them we have. They shouldn't change to something else. If I say I have 2 apples and 1 apple, so I have 3 oranges. No, you still have 3 apples, right? So these ones right here, minus 5x squared plus 2x, that's going to be minus 3x squared. And then the x just stays on its own, plus x, and the minus 1 just stays on its own. Now, by the way, this is a 4-term polynomial. We don't really have a fancy name for it, but the degree is 3. It's the highest power, right? All right. Example 4. Let's try subtracting polynomials. So, parentheses, 4n squared, we can use different letters than x, minus negative 2n squared plus 2n minus 4. Okay? So we have a binomial, degree 2, and a trinomial, degree 2. And the way you're going to know that you're subtracting is there's going to be a big subtraction in between them. Okay? Now what we need to do is we need to distribute that subtraction. And really that subtraction is like a negative 1, right? So we're distributing a negative 1 into each of these terms. Okay, when it was addition, we didn't have to do anything special to get rid of the parentheses. So the first thing I'm going to do is rewrite this without parentheses. 4n squared minus 5 stays the same. Negative 1 times minus 2, that's positive 2n squared. Negative 1 times 2n is minus 2n. Negative 1 times negative 4 is positive 4. So you're really just like flipping the signs of everything inside there. That's what happens, right? The next thing I would do is I'd rewrite it so that the highest powers were at the beginning down to the lowest power. So we have a 4n squared, and we have a plus 2n squared. And the next would be the minus 2n, and then the minus 5, and then the plus 4. So left to right, smallest to biggest. So these are like terms. So that's going to be 6n squared. This guy is on its own, minus 2n. These guys are like terms, so that's minus 1. So this is your final answer. This is a trinomial, by the way. It has 3 terms. Its degree is 2. That's the highest power. Okay. Now, I'm going to give you guys a couple examples, and then we'll be done. So I'm going to write these down. After we write them down, I want you to pause the video and try these on your own, and then unpause it, and we'll check your answers. So the directions might just say simplify, which means to add and subtract and things like that. So first example is going to be parentheses 3x squared plus x minus 6 plus parentheses x squared plus 4x plus 10. And the other example, part B, is going to be parentheses 4x squared minus 3x plus 5 minus 3x squared minus x minus 8. So those are the two examples. Write those down, pause the video, see if you can do them, see if you're ready to do the homework on your own, and then I'll go through it and you can figure out what you messed up. All right. Okay, assuming you have tried them yourselves. This one, since it's just addition, we're just going to go through and write the biggest power terms in order. And cross them out as I go. This is that's a 1x, right? That's a 4x. And then a minus 6 and a plus 10. So I cross them out just to make sure I don't miss any of them. Now, these guys are large terms if that's like a 1 in front, right? So that's 4x squared. Do not add the exponents, right? We're counting how many x squareds. I got 3x squareds and 1x squared, so I got 4x squared. Still counting. This is going to be 5x, and negative 6 plus 10 is positive 4, so I'm going to write plus 4. So this is our answer, simplified in standard form. If they asked you, this is a trinomial because it has 3 terms. It's degree 2 because the highest power is 2. Okay, B, you got to watch out. You got to distribute this negative. So the first thing I do is I rewrite the whole thing. 4x squared minus 3x plus 5. I can just drop those parentheses. Nothing happens. Minus 3x squared plus x plus 8. Make sure you distribute that correctly. Then I'm going to put them in order. 4x squared minus 3x squared minus 3x plus 1x plus 5 plus 8. So combining like terms, that's going to be 1x squared, 4 minus 3, minus 2x plus 13. Now for the final answer, we usually wouldn't write the 1. 1x squared is the same as x squared. So if you wanted to, you could just have written it like that on the last step if you were thinking ahead. Now, today for your classwork, you're going to do monitoring progress. And this is out of the book. It's on the bottoms of the pages of the book that are in section 7.1, starting at page 358. And we're going to do problems 1 through 11. Now, I would do it through the Student Dynamic ebook online because if you do it there, there's these little blue arrows next to each problem that if you play, will show you exactly how to do each problem. If you're getting stuck at all, if you just want to check your answer. But you got to be zoomed all the way out, I think, for the little blue arrows to work. But that's it. That's the notes. Try the monitoring progress now.